All right, so for Algebra 1, here I'm basically making a bunch of videos going over all the notes that we've gone over in class, so that if you missed a day or anything like that, so then you'll have the notes here on hand, um, so we can go from there. So we'll start from the beginning in Unit 4. I'm going to start with Unit 4. I'm going to try and do this for all the other units as well. And remember that Unit 4, the first topic section that we were doing was 4.1, which was just graphing linear functions with tables. So this first kind of part here, these first couple parts, I kind of ended up skipping, and I went just straight to kind of just graphing the function with the table. So just remember that our x value, remember this is our input right here. So we're going to use this to input into our equation. And then whatever my y value is, that's going to be my output. That's something that I'm going to get because I plugged in my x, all right? Now, our x values that we plug in over here can be any number, all right? We can literally plug in any number that we want to plug in. But if we take a look at our table over here, or our graph over here, we have our x-axis and our y-axis. Well, our x-axis is going to be basically all of these numbers right here. So we kind of want to pick, a good amount of x values that we can see on our x-axis. So I'm just going to pick these x values right here. So I'm going to go from -2, -1, 0, 1, and 2. All right, it's kind of tough to see down there. And when we pick the -2 here, what it basically means is that we're going to take this -2 and we're going to plug it in to wherever we have an x in our equation. So right next to the 2 there. So what that basically means is that we're going to do 2, and because we plug the -2 in, we're going to plug in a -2 and multiply these two numbers together here. And then we still have the -1 at the end there. So let's take a look. 2 times a -2 is a -4. -1 is a -5. So we're going to put -5 in for our y value, okay? And then when we get our ordered pair that we are going to graph over here on the graph, we're basically going to put our x value, again, as our first number, and our y value as our second number. So it's going to be -2, -5. And we repeat the process for all of them, all right? Plug in the -1 here, -1, -2 times -2 times -2 times -1 is -2, -1 is a -3. So, and then in my ordered pair, first number is the x, which is -1. Second value is the -3. Then same process for the 0. 2 times 0 -1. 2 times 0 is 0. -1 is a -1. That's going to be my ordered pair. First number is the x, which is 0 over here on this side, and then the -1 right here. All right, and then I'll kind of quickly go through the rest of them there. 2 times the -1 is 2 minus 1, turns into 2. Ordered pair is going to be 1, comma 1, and then last over here you have 2, plug in the 2, -1. 2 times 2 right there, right here is 4. 4 minus 1 is, is 3, okay? And then we plug in 2, 3, okay? So again, that's basically filling out the graph of the function. Our x values, those are going to be our input. We are going to input those to our x right here. And then whatever we get out is going to be our y value right here, okay? So the last thing we need to do is go ahead and graph our ordered pairs that we got right over here. So I graph -2, -5, that is -2 to the right here, and then up, and then down 5, -5, so go down 5. -1, -3, I go to the left 1, and then I go down 3. 0, -1, 0, I don't move anywhere on the x-axis, and I go down 1. 1, 1, I go to the right 1, and then up 1. 2, 3, I go to the right 2, and then up 3. And then I should get, and this is going to be, hang on, I think I lost one here. 1, 3 here. No, wait. 5, -1, 3, which is right here. There it is. And it should look like a fairly straight line. Doesn't have to be super straight, but it should look like something like that, okay? All right, so we got this other one here, y is equal to negative x plus 3. I'm going to basically pick, the same numbers. Again, I would suggest picking any numbers from the range of, basically the range of your graph. So if your lowest number is negative 10, highest number is 10, I wouldn't pick any numbers that are less than negative 10 or bigger than 10. So again, I'm just going to plug in my negative 2, negative 1, 0, 1, and 2. And I always recommend plugging in the 0, all right? Because the 0 is kind of a, oh, come on. Make sure the pen's back here. So the 0 is always kind of the easy one to plug in, all right? Because the 0, when you plug the 0 in for x, so let's just go ahead and plug in 0 in for x. So it's going to be negative 0 plus 3. Well, the 0 just makes the x go away, and all you're left with is the last number there, which is 3. So it's going to be just y is equal to 3, which is going to be our ordered pair here, okay? Then we have our x, negative 2. We're going to plug it in to our negative x up here. So it's going to be negative of a negative 2, okay? Because it's the negative time. This basically right here tells me that it's negative. It's basically whatever number you plug in there, you're going to multiply by a negative 1. So this is going to turn into a 2 plus 3, which is basically 5. This is going to turn into, essentially right here, a 1 plus 3, which is 4. I'm going to write my ordered pairs over here. And then down here, this is going to be negative 1. Negative 1 times negative 1, which is just negative 1 plus 3, which is 2. So 1 times 2, 1 and 2. And then I plug in right here a 2. This negative turns that 2 to a negative. Oh, come on. Oh, darn it. There it is. And plus 3. Come on. Sorry about this, y'all. So negative 2 plus 3 is 1, so we plug in our ordered pair to 1. And then from there, we graph our points right over here, okay? So it's going to be negative 2. I go left 2, up 5. Negative 1, 4. I go left 1, up 4. Come on, leave it there. 0, 3. I don't move left or right at all, and I go up 3. 1, 2. I go right 1, up 2. And then 2, 1. I go right 2, up 1. And again, you should have a straight line. It should look like a straight line like that, okay? All right, so again, that's basically just graphing our points, all right? Graphing our functions using a table. We essentially plug in any number we want for our x value here, and then we essentially fill out the rest of our table. We get our y values, and then we take that and graph them over here, okay? Okay, so I'm going to move on to the other PowerPoint. I'm sorry. There should be another PowerPoint here. Is it a function? And this is basically going to be the second part of this video, which is essentially, and the second part of 4.1, which is essentially basically determining what is a function and also kind of an introduction to domain and range, okay? So, and I forgot to write it here, so I'm going to kind of write it over here. But domain is essentially all the possible x values. So it's basically all the possible x values. And range is all possible y values, okay? So it's basically all the possible x values for domain, all the possible y values for range, okay? Now that's kind of the quick thing on domain and range. Now let's look at basically relations and functions, okay? So the relation is essentially a correspondence between a domain and range. It essentially means that one number in our domain is matched to a number in our range, okay? So say if we have the number 1 in our domain, it's matched to the number 2. Or then we have 2, it's matched to 3, and so on and so forth, okay? Now, a function is essentially a special kind of relation in which each element of our domain, so basically our domain right here, is matched to exactly one element of the range. Come on. Of the range. Now, basically what this function definition is saying is that none of your x values can be repeated for it to be a function, okay? There can be no x values to be repeated for it to be a function. So let's look at this right here, okay, this first example here. Let's look at all of our x values, which would be this, 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 and this. Do you see any numbers that pop up twice? I don't see any. 1, 2, 3, 4. So I would say that yes, I have myself a function here. Now for the domain, I'm just going to, if it's all my possible x values, well, I'm just literally going to list out all my x values. So it's going to be 1, 2, 3, and 4. Okay. For the range, it's all my possible y values. Again, list out your y values. 4, 7, 6, and 7. You do notice that the y values do repeat, but I don't really care about the y values for when it comes to functions. Y values can repeat all the time. All that I care about when it comes to a function is whether or not my x values repeat. Okay? So let's go, oh, this one's a little bit chopped up here. All right. Let's move on. Let's do this one here. All right. So these are my x values here, my inputs, and these are my y values. I have 2 going to 4, 3 goes to 8, 4 goes to 8, and 5 goes to 5, okay? Now, if I were to write this out kind of as ordered pairs, it would be, 2, 4, 3, 5, 3, 8, excuse me, 4, 8, and then 5, 5. And again, notice that your x values don't repeat, all right? In this instance over here, it's essentially this value here is matched to exactly 1y. This 3 is matched to exactly 1y. 4, 1y. 5, 1, 5. So because none of my values here repeat, my x's are matched to exactly 1 point in the domain in the range, I do have a function. And again, the domain, I just list out of my x values. My x values, these ones right here, just list them out. 2, 3, 4, and 5. In the range, my y values here, list them out over here, just 4, 5, and 8. Okay. Now if we go over here to this one, we notice that I have this 4 that goes to exactly 1, 7, 1y, but this 5 goes to not 1y, but to 2 y's, all right? And again, if I were to write this out as ordered pairs, it'd be 4, 2, 5, 2, 4, 7, excuse me, 5, 8, 5, 9, and then 8, 5. And you notice that your x values repeat, so no, you do not have a function here. I'm still going to list out the domain, which would be, again, your x values, 4, 5, and 8, your y values for the range, 2, 5, 7, and 9, okay? All right, now, the last thing that we need to do here, I'm going to do this real quick, I'm running out of time, is we need to figure out if the ordered pair is a solution. Now, you have a line here. Basically, what you want to figure out is, does this ordered pair, this is a line right here, so it's essentially going to be this line here. Does this ordered pair fall on my line? Wherever this line is, will it fall on that? And the way that I figure that out is I essentially plug in this for my first value for my x, my last value for my y. So I'm going to plug in the 1 for my x and the -1 for my y. I'm going to do it out. 3 times 1 is 3, plus 2 times -1 is -2. You simplify that out. That is true. So therefore, yes, this ordered pair is a solution. And you do the same thing. You'd plug this -4 in for this x and the 6 in for this y. Okay? And see if they match. Thank you guys for following along. New video will be up very soon.